Good morning and welcome to section 5.2 proportions. We're going to learn that there's about a million different ways to determine whether or not a proportion, two ratios are proportional. So I'm going to start here with a proportion is an equation stating that two ratios are equivalent. Two quantities that form a proportional are called proportional. So these two numbers, 2/3 and 4/6, are proportional. So how do we determine whether or not ratios are proportional or not? The easiest way to tell whether they are or not is to, get your pen out, is to put them in their simplest form and tell that way. So if I take 6/4 and I simplify that and I divide by 2, I get 3/2. That's in its simplest form. If I take 8/12 and I put that in its simplest form, I get 2/3. I divide the top and the bottom by 4. Since those are not the same, they are not in a proportional, they are not a proportion. We probably could have seen that when we looked at the two ratios anyway, because 6/4 is a improper fraction and 8/12 isn't. So there's no way they really could have been simplified down to the same ratio. If you have a table and you want to see whether or not those quantities are proportional, you actually have to take every single value in the table and compare them to each other. So we're going to compare the ratio x to y in simplest form. So we're going to say 1/2 to 3. Well, if I keep it and I change it and I flip it, oops, sorry.
Sit. Sit, Butterby. Sit. Sit. Butterby, sit.
And I make that 1/3, I'm going to end up
Sit.
with 1/6.
Sit.
With her around, he's probably not going to.
Sit.
If I take this line and I compare 1 to 6, well, that is 1/6. I don't really have to do much to that. If I take 3/2 and compare it to 9, so 3/2 to 9. If I keep that and I change it and I flip it, I end up with 3/18, which simplifies to 1/6. And we can't fit the 2/12, so I'm going to fit that over here. So 2 to 12 does simplify down to 1/6. So since everybody is equal to 1/6, then the table is proportional. So try on your own to see whether or not these numbers are proportional. Pause me and then bring me back. Hi, welcome back. Well, 1/2, if I simplify 5/10, that does simplify down to 1/2, so those two are in a proportional relationship. So that would be yes. If I simplify this, I get 2/3, and I simplify 8/24, well, 9/12. And I already know that I can't simplify that down to be 2, so this is not in a proportional relationship. 10/3 to 5/6. Again, if I look at this, this is an improper fraction, and this is not, so there's no way they could be proportional. I don't have to do much there. If I take these and I start to simplify this, I get 5/4. I divide the top and bottom by 5. If I divide the top and the bottom by 3, I get 5/4. So yes, that is in a proportional relationship. Now if I look at this table and I simplify, well, 1/12 is simplified. 2/24, I simplify that down to 1/12. These two can also be simplified to 1/12. So this table is proportional. Okay, there is another way. The two other ways to determine whether or not something is in a proportional relationship. So let's see. If you swim your first 4 laps in 2.4 minutes, and you complete 16 laps in 12 minutes, is the number of laps proportional to your time? Well, we can determine this by comparing the unit rates. So if I say 2.4 4 minutes and 4 laps, and I take the unit rate, I can get 0.06 minutes per 1 lap. And if I compare this 12 minutes, so I'm going to cross that out, 12 minutes to 16 laps, and that turns out the unit rate is should be, the point should be there, 0.6 minutes, and the 0 is, so this is actually 0.75 minutes over 1 lap. And no, they're not the same. The unit rate are not the same for those two, so no, it is not a proportional relationship. So no. However, there's a third way you can do this, and that's called using the cross property. And I'm going to go back up here. The cross property means that I take the top of the first ratio and multiply it by the bottom of the second, or the numerator of the first ratio by the denominator of the second ratio, and then the numerator of the second ratio times the denominator of the first. So if I multiply these, are these in a proportional relationship? Well, 2 times 6 is 12. It's equal to 3 times 4. That is 12, so yes, that is proportional. So let's try that down here. We already know that this isn't proportional, but we'll try it anyway. So 2.4 minutes over 4 laps is equal to 12, or is it equal to 12 minutes over 16 laps. So we're going to multiply 2.4, this little butterfly thing. So 2.4 times 16, is that equal to, I'm going to do the other side of the butterfly, 12 minutes times 4 laps. Well, 2.4 times 16 is 38.4, and that is not equal to 48. So since the cross product is not equal, no, it is not a proportional relationship. Okay, be on your own. Take a pause and see whether or not you can get that one, and then come back and join me. So welcome back. Well, let's see whether or not these are proportional. I'm going to do my work up here. So 20 pages in 25 minutes. Is that proportional to 36 pages in 45 minutes? Now, the key to writing proportions, and we'll talk about this in a later unit, is making sure you're comparing like things. So pages to minute. As long as that's consistent, you're good. So 20 times 45, is that equal to 36 times, oops, I'm off the page, times 25? And it turns out that 900 is equal to 900, so they are proportional. Thanks for watching.